Hi there! In this video we will review three different programming languages for checking API: Java, TypeScript and Python. We will make calls to the small hotel booking API. We start this quick review with Java. Let's walk through the POM file and see what's inside. So we can see RestAssured dependency. This is the main library for sending httpx requests and checking API responses in test. JSON databint helps Java convert our objects into JSON. JUnit Jupyter gives us the test runner that executes our tests. The Surefile plugin runs our test when we execute Maven. It's what actually launches JUnit and reports the results. In general, this Maven file says use RestAssured to call the API, JSON to convert data to the JSON, and JUnit to run the test. Let's move to the actual tests. When we run a test, the code starts with before all method that runs before any test in the class. Inside it, we prepare shared things such as base URL, headers, and authentication token. Everything we can see we pack into spec variable, and it's basically a reusable variable that holds common request settings. So instead of repeating those settings for every API call, we build them once in setup and then reuse them with given .spec methods. After that method finished successfully, JUnit moves to the first test method. Let's see what third method test says. Create a booking and check that the API returns a valid response. First, it builds a booking payload with sample data we are creating here. Then it sends the payload to the API using a POST request. After that, it checks the response. Status code is 200, which means the request was successful. It also checks the response contained the booking ID, and the returned booking data matches the data we sent. As you can see, the code is written in a very readable style because it uses a chain of methods. That is why it feels less like a programming code and more like a sentence. Sends this booking, then verifies the API answer. Now let's look on the second test. There is an explicit assertion for the token value. In test 3, there is no assert keywords because the checks are expressed with RestAssured Fluent style. Now let's run all the tests. We see all tests are green and passed, and also we can see that all the tests take 170 lines of code. Now let's move to the TypeScript approach. We can see node modules. This folder contains all the installed libraries and packages the project needs to run. It's created automatically when we install dependencies. Test results. This folder stores output from the test run, such as screenshot, logs, or other generated files. It's mainly for debugging and reporting. Tests is where the actual test file lives. Package log JSON. This file logs the version for the installed packages, so the project is more stable and reproducible. Package JSON is the project setup file. It says what dependencies the project needs and what commands we can run. It's a project instructions. Playwright config.ts is a configuration file. It tells Playwright where the tests are, what base URL to use, and how to run them. TS-config.json, this file configures TypeScript, telling the compiler how to handle the code, which JavaScript version to target, and how strict the check should be. Let's dive into test file and see how the test looks like. Here we can see interfaces. It's the shape description of the data objects. Login and create booking functions, small reusable pieces of logic. Test blocks. Each of these is a test case. expect checks that the API response is correct. The test file reads like a sequence of actions: send a request, check the response, do the next step. Why there is no before all as in Java? Because Playwright request fixture is created per test, not shared. What is a fixture? Fixture is something Playwright gives to test automatically. In the test one, this line, we can say that fixture is passed into the test as an argument. This part in curved brackets request is a fixture injection syntax. So a fixture is a piece of setup that injected into a test automatically when the test asks it by its name. So what do the interfaces mean? The interfaces are TypeScript type definitions. This means this object must look like this. It helps TypeScript understand the shape of the data. Important here is that interfaces do not run anything. They only help the compiler check the code. So they are like blueprint, not real functions. Now we run all the tests together. From the project folder, we can run all tests with this command. All tests passed, and we can see that all the tests take 120 lines of code. Now we are moving to the last part, Python setup. What is inside the Python project? PyCache. This is a folder created by Python to store compiled bytecode so Python can run your code faster the next time. Pytest cache. This is created by Pytest to store information about the previous test runs, such as cached results and metadata. venv. This is a virtual environment folder. It contains an insulated Python installation and its own packages, so your project does not mix with the system Python. Tests. This is a folder where all test files lives. conftest.py. This file defines shared test fixture. It prepares things that many tests can reuse. Pytest.ini. This is the Pytest configuration file. It tells Pytest where the tests are and how to run them. Requirements.txt. This file lists the Python packages the project needs. Test booking API. This is the main test file. It contains the actual API tests. What is import httpx? httpx is a Python library for making HTTP requests. In this project, it's used for send requests to the API, received responses, read JSON, and status codes. Dev defines the functions. Sample prepares the request body data for the booking. Create booking uses the data to create a booking through the API. So they are helper functions that prepare the input for the tests. Let's look on the first function. The client argument is provided by Pytest from the fixture defined in conftest.py. How do we run all the tests? First, we need to create and activate virtual environment. In our case, the folder already exists as venv, so we need only activate it. Here how we do it. Why do we need to install virtual environment venv? Because Python installs packages globally by default. And for example, if project A requires Pytest 7.0 and project B requires Pytest 8.0, they conflict. A virtual environment just isolates Python for a one project, separated from everything else on our machines. Think of it like a Docker, but only for Python dependencies. We see all our tests passed, and now I want to deactivate virtual env. And we can see that all the tests take less than 100 lines of code. Thanks for watching. I hope it was useful and interesting. See ya!